Okay, so this is the second video for worksheet 21.5. So let's carry on. For question 5, right, I will not spend much time to cover it in the video because most of it, like for part 1, this is the standard answer to explain how the voltage is being induced in the secondary coil of a transformer. Then part 2 is just an application of the transformer equation. Just to take note, remember to have the unit as turns, not coil. Okay, there's only 2 coil in the transformer, primary coil, secondary coil. Each coil have different number of turns. Then remember for physics is round to 2SF. Okay, then for part 3, I will spend some time to explain to you. So for this, it is also in your notes also. This is asking you why you need this soft iron core, right, in the transformer. So basically, it serves 2 purposes lah. But in this case, the question's focus is on why is it that you want to use soft iron as the core, not so much on why do you need the core. Okay, so there are some students who answer the question as why do you need the core, and you may not get the full mark. The question is asking why soft iron is used. Why not use a steel core? So in this case, right, you need to talk about the key property of soft iron, which is your soft. Why soft versus hard? What is the difference between soft versus hard? It's not the strength of the magnet, but rather the responsiveness. Okay, so you need to bring in this idea why you want to use soft magnetic material. Soft magnetic material, it can be magnetized very quickly. It can also demagnetize very quickly. So the difference between hard and soft is actually how responsive the material is. And then secondly, you also need to answer why do you choose iron? Why not titanium? Why not copper? Right? So we need to talk about this thing called magnetic material. Why do you want to use a magnetic material as your core? Why not use non-magnetic material? So in your answer, you need to use your answer and highlight these 2 key properties. So for the why do you want to use magnetic material? Because only magnetic material can redirect and concentrate the magnetic field line to the secondary coil. So this will answer why do you use a magnetic material. Then why do you want to have a responsive material? Why not use steel, right? So to share with the marker, why do you need a responsive material? You need point number 2, right? Because the primary coil is producing an alternating magnetic field. So the material need to respond to this magnetic field keep changing direction. Yeah, so you need that. Okay, in some of your answer, I also see that some of you like to use this word, I want 100% transfer. In physics or in real life, right, it's impossible to get 100% one. Later on in uni, you will learn there's this theory that says that the state of the randomness or the chaotic state will get worse and worse. So you cannot get 100%. Okay, so because of that, try to avoid absolute term like, I want 100% transfer. I want to prevent heat loss. All these things cannot. You can't prevent heat loss, right? You can prevent conduction. You can prevent convection, but you cannot prevent radiation, right? Even if you create vacuum, radiation will still happen. So there are things that you cannot prevent. Okay, so avoid absolute terms. Okay, then lastly for part 4, this basically tests whether you can still recall some of your practical electricity questions. So I'm not going to spend time going through, it's just facts. So you can pause the video and check your answer. There are a few things you need to take note. Number 1 is that you need to highlight because they give 4 answer lines. So you need to give a bit more detail than normal. Okay. The key factor about the safety feature earth wire is that earth wire itself is a lower resistance path, and it will redirect the current from the user. Okay, and that will protect the user from electrocution, right? So if you really feel insecure why there's still one more line, you can even, like I say, add in you can also add in like it will hence redirect the current from the user, right? And as a result, it protects the user from electrocution. So it's really up to you. Okay, for question 6, question 6 actually it is a kind of like a tricky question. So I need you to really check your answer thoroughly. Okay, why is it tricky? Because actually most of the time when in the notes, the graph of the CRO is actually connected to the input coil, but in this particular question it is connected to the output coil. So you need to give yourself a mental note that when you see a curly graph, the curly graph actually refer to the output, not the input. Alright, so as you carry on, part 1 I'm not going to cover in the video, it's just a definition. Part 2 is a similar question in question 5 part 1, so refer to that. I will focus on the calculation here. So like I said, this particular cathode ray oscilloscope curvy graph is for the VS, the secondary coil. So you need to know that this is the secondary coil reading. Okay, so once you remember that this is the secondary coil reading, then you need to read the graph. Then some of you are not very flexible in your thinking. So in this case, you can see the graph given to you in terms of division. So what is this division referring to? So the division refer to this one. Like that is one division. So one width is how long? 10 milliseconds. So if now I want to read this particular graph, what is the time taken to generate this one waveform? It will be 1, 2, 3, 4. So it will be how much time? 4 times 10 milliseconds from here, right? And then what is the Y gain? Y gain refer to this division of Y gain in the Y direction. So how do I read the Y gain? It will be from here, read till here lor. So 1 box, 2 box. So what is the amplitude of the VS? 2 times 5 volt, which is 10 volt lah. So once you have all this info, right, you can actually answer this question. And one of the key ingredient is also here. Okay, so I already write down the working here. How to find the frequency? Well, I can find the period, right? I can find the period, and from the graph, I know that my period is 4 times 10 milliseconds. So to convert millisecond to second, you need to know your prefixes. Then after that, just use the equation F equals to 1 over T. Okay, for part 2, you just need to state the formula, so I don't even bother to write it down. Okay, for part 3, okay, like I said, the curly graph is for secondary coil. So using the Y gain and to read the graph, you're able to see that the amplitude for the voltage output is 10 volt. Then after that, you apply your transformer equation together with this info, okay, the one on red underline. Then you can actually turn this into a ratio, right? MP over NS, although you do not know the exact number of the turns, but you know that it is 4 times, right? So if I know that it is 4 times, then I can just turn this MP NS into a ratio, and that's how I get the answer. Alright, okay, we will push for one more question before we take a break. Okay, so for question 7, it is an O-level question. Okay, so why I pick this question is, if you recall, right, previously in the same video, this video, I think it's this video, we asked ourselves, why do we want a soft iron as a core, right? Then after that, in another year, instead of asking why do you want iron as the core, they ask you, why do I need a core, right? Why do I need a core? So this question and the previous question, the focus of the question is similar but different. One asks why you want iron. The other asks, why do you even need a core? Right? So to answer this question, basically, the main reason why you need a core is you want to increase efficiency. Actually, only one reason. But they wanted you to break it down into two reasons. So what you need to do, you need to elaborate lor, right? So this is the elaboration. Why do you need a core? Well, the laminated core will actually increase the resistance and reduce the ND current. So if you thinking like, hey, teacher, you got teach ND current, right? I didn't teach, but it is in the notes. So you check the transformer notes, ND current is there. There's a video also about ND current. Okay, then the second reason how the core can increase efficiency is about redirecting and concentrating the M field line to the primary coil. Okay, you can pause the video and copy the answer. Then after that, it's about calculation. Like I said, just read carefully and remember to put down the unit turns. Okay, so now we can take a short break and I will continue the worksheet with a third video.